Hi everyone, today we will talk about gap theorem. Let us start with a story. Suppose you have created a photo storing app. The app became very famous and you have got a lot of users of the app. Now what happens? User stores a photo using photo storing app and the photo is stored on a server. So whenever user wants to get his photo, download his photo or see his photo, a request is made to the server and user is able to see the photo or download the photo. Now the app is doing really good. It is becoming popular and currently you are able to serve 100 users with one server. So you would like to serve more users and make more money. So you bring in one more server. So we can serve more users parallelly with multiple servers, right? In this case, we add one server. So for simplicity, let us give names to this server. This is called server A and this is called server B. Now our user is trying to upload a new photo on Photo Store app. So he uploads a photo and Photo Store app connects to server A and sends the photo to server A. After 5 hours, our user wants to access that photo and it makes a request to Photo Store app. So our Photo Store app this time connects to server B, but server B doesn't have the photo. So it will send a response that I don't have the photo and Photo Store app will show that response to user. Our user in this case will be very annoyed and surprised that where is my photo? This is called consistency problem. So this has happened because server B doesn't know what is server A storing and server A doesn't know what is server B storing. So it is important that these two servers should be connected with each other and should be telling each other that I am storing this photo. Let us connect them. Now server A and B should be telling each other that what are they storing. They should make a rule that before serving the next request, they should always make sure that they tell each other that I have this data, I have stored this photo. So that if the view photo request is made exactly after storing the photo, the result is always consistent. Great, we have solved consistency problem. Now let us talk about next problem. Suppose our server A stops working. Now our user wants to store another photo. So it will upload the photo using Photo Store app and Photo Store app will make a request to server B. But you remember we had created a rule that before fulfilling any request, user B and A should always share the data. In this case, B will not be able to share the data with A because server A is down. So what is happening here? Because one of the servers has gone down, other servers are not able to serve our user because in this case consistency will get impacted. So this is called availability problem. Even though lot of servers are still up, only one or few servers are down, we are still not able to serve the user. This is called availability problem. Now how can we solve the availability problem? We should create a new rule that in case one or more servers go down, other servers should keep on fulfilling the request of user, and whenever server A comes up, the first thing they should do is share the data with each other so that they become consistent, and after that server A can start responding to the user's request. If we create this new rule, it will make sure that consistency and availability both are taken care. For a period when server A was down, the performance of our system will be low, but it will be taking care of both consistency and availability. Now let's talk about a third situation. Suppose server A and B both keep on working, but the network link between them is broken. So this has created partition within the cluster that server A and B are not able to reach each other and share information, but server A and B can talk to Photo Store app. Okay, so whenever user makes request, it can go to server A or it can go to B. Now server A and B both can serve the request to customer, but if we store the data on server A, even though the server B is alive, it will not know what are the new photos being stored on server A. If the request is served by server B, A will not get to know that what are the new photos being uploaded on B. This will make it inconsistent. Or we should create a rule that A and B both will not serve the customer. This will create a availability problem. This is called partition tolerance problem. So whenever there are two partitions within the connected servers, you have to either sacrifice consistency or availability. So either we will be able to serve the user, but A and B will go out of sync, or A and B will completely stop serving the customer. So this is in nutshell is cap theorem, that whenever there is a partition tolerance, you have to sacrifice either consistency or availability. So it depends on your application that you want to sacrifice consistency or you want to sacrifice availability. For a banking application, consistency is very important. Imagine a case where you had 10,000 rupees in your account, you went to ATM and you withdrew 10,000 rupees, and then for curiosity, when you checked your account through your mobile app, you still saw 10,000 rupees in your account. And what if you transfer that 10,000 rupees to your brother's account? And ideally, the transaction should not be allowed. But it sounds very stupid that you don't have any money in actual, but because of system inconsistency, you are still able to transfer money to some other account, right? So for banking application, consistency is very important. For some applications like social media applications, consistency may not be important. Imagine a case where you and your friend are commenting on other friend's photo and saying, oh, it's very nice, oh, it's really good and all that. And so even though you had posted the message first of congratulations or it's a very nice photo, then your friend, still the system is showing that, okay, your friend has posted the message first. So that's not a major problem in case of social network kind of a platform. But in banking application, it can be a big problem. In some situations, availability is a major challenge. So in banking applications, you will say that, okay, I'll not serve my customer for 2 hours rather than corrupting my data. So you will sacrifice availability. In social media applications, you will say, okay, I like availability, but it's okay if the consistency is taking a bit of it. So during a partition tolerance, when network is broken or something happens, two servers in the cluster are not able to talk with each other, you have to choose between consistency and availability. So when that network comes up, then say A and B will again start to talk with each other and they will share the data with each other and system will behave normal as if nothing would have happened, and it will become consistent again. So that is called eventual consistency. So system will eventually reach to a consistent stage. Let's talk about slightly modified version of cap theorem. So cap theorem comes into picture when there is a partition tolerance that has happened. At that situation, you will choose between consistency and availability. So what happens when there is no partition tolerance? So this is the case we are going to talk about. So when system is behaving normal, in that situation, you have to choose between latency or consistency. So since there is a data sync happening between server A and B, so there will be some time lost to sync the data between server A and B whenever there is a request sent by user. That will add some latency to serve any customer, to serve any user request. So we are saying here, you can either make system very consistent or add some bit of latency while serving the user. So when there is no partition tolerance, you have to choose between a very fast responsive system or very consistent system. So that's what PACELC theorem talks about. Let's talk about bit of theory. So cap theorem is a fundamental concept in distributed computing. Generally, it is used to pick the right database for your application. It is one of the guiding principle for designing application. So when you are designing a distributed application, right? So this principle helps you make a lot of decisions in simple way. So another way of stating cap theorem is that you can only pick 2 out of 3: consistency, availability, and partition tolerance. You cannot have all 3. So consistency says every read request receives the most recent write or an error. In consistent systems, all nodes in the system have the same data at any given point of time, ensuring that client receives the latest data. Okay. Now availability means that every request that you send to the system is always served. You may end up getting slightly old data, but your request will be always served. Partition tolerance means that how will your system operate when there is a network failure and few nodes are not able to talk to each other. So it's system's capability to keep on functioning when there is a network failure within the nodes. That's all. I hope you enjoyed the video and learned something. Please like the video and share it with your friend. Please also subscribe to my channel.